on it. And know that some people will ask, because I asked you to just do arbitrary ones. So someone might have done one that you didn't do, so feel free to fill in that. It doesn't get you any more points, but just so you have a knowledge. Any that I could help you with that you struggled with? Any particular one? Yes, ma'am. 16. Okay. Number 16. Okay. First thing I want you to do in this kind of problem is to realize, let's see if we can factor by grouping, and that might lead us to it factoring easily. If not, we then would go to decimals. Okay? All right, so first thing I'm going to do is I'm going to look at my first two terms. What's the most x's I could factor out of those two terms? What do you think? And just so you know, x to the third is xxx. Then I have minus 5xx. How many x's can I factor out of those two terms, do you think? Two of them. Yeah, so I'm going to go x squared, take it out. If I get rid of those, I'm left with an x minus, get rid of those, minus 5. That seems okay so far. Agree? I'm then going to look at this. And remember I said this sign will come down. What can I factor out of 3 and 15? 3? If I factor 3 out of 3x, I'm left with an x. The minus sign comes along. What can I factor out of 15? Or 3? If I factor 3 out of 15, what's left? 5. Okay, so this one looks like it's going to work out. The reason I know it's going to work out is notice I have an x minus 5 and an x minus 5. Those are called binomials. Agree? So I'm going to look, say, okay, I have these two in common. I'm going to factor x minus 5 out. And what do I have left? Well, I have this and I have this. So I'm just going to put those together. And we're done. It's factored. Sorry, getting in the way. Do the best I can to be in the way of everybody. What else on problems might you want to take a look at? Yeah. So yes and no. If it factors, no. Like if it factors real easily. If it doesn't factor, then go to decimals, figure out where it's crossing the x-axis, pick one of the points, use synthetic division, start breaking it down. Anyone want to see one that we probably have to use synthetic division on? Make sure we feel good about? Okay. Let's take a look at number 19. Okay, so this is what I mean when this is not going to work on conventional methods. If I look at these first two terms, realize I have this. So I could factor an x squared out. That leaves me 2x plus 5. If I go to this part right here, I could factor a 1 out, which doesn't change anything. And notice, this binomial and this one are not the same. Agreed? Does that make sense? These are not the same, so if I highlight those, this and this are not the same. So I can't factor a binomial out of those now. Okay? So once that happens, and I asked you, any of you download Decimos yet to your phone? You're more than welcome to have your phone out and bust out and go to Decimos. But I have to add my keyboard so I can go to Decimos. All right, so I'm going to head over to my friend Firefox. Go to Decimos.com, graphing calculator. Yes, this is a free site, which is great. You're going to kind of cheat the system a little bit. You're going to have there's not a y equals there, but you're going to go ahead and put a y equals in regardless, okay? Which number we're doing, 19? So I have 2x raised to the third. Make sure it doesn't stay up there, so you use your arrow to move over. Plus 5x squared plus x, plus x minus 2. Okay, so notice I click on Desmos, each of where it crosses. We have 3 different things. These are all the X-intercepts, okay? So at negative 2 comma 0, X-intercept. Okay, it's also called the solution. Negative 1 comma 0 also, and then 0.5 comma 0. I don't ever recommend doing synthetic division with a fraction. We don't like fractions. It's the F word in math. We don't appreciate it, okay? So I'm going to either pick negative 2 or negative 1 to start my synthetic division. Give me a shout out. Which one should we do?
Negative 1.
Negative 1? You got it. All right. So negative 1 we chose. I'm going to go back here. We chose negative 1 as our synthetic division. Okay, so I'm going to go negative 1. I'm going to make this upside down bracket. And what I'm going to do is, first thing I'm going to make sure I have to the third. Oops, I didn't want to do that. I have to the third power, to the second power, to the first power, to the 0 power. Okay, so it's descending order. If we were missing, if we went from x to the third to x, we have to put 0 in as a placeholder. But we don't have that in this case. So then I'm just going to take the lead coefficients that I have up there. So I have a 2, I have a 5, I have a 1 right there, and I have a negative 2. Does that seem okay? Do you see where I got those numbers? I straightened my back on the wall. You guys did nothing wrong. Okay, so when we do synthetic division, the very first thing you do, you just bring this straight down. So 2 comes down. Okay, it's the most ridiculous mathematical operation in the world. What do? Bring it straight down. That's not add, subtract, multiply, and divide, pal. I know, this is just the tool that we use to make it work. So 2 times negative 1 is negative 2. Do you agree with that? Go ahead and add up that column. So 5 added to negative 2 is 3. Now I'm going to take that bottom 3. I'm going to go 3 times negative 1. 3 times negative 1 is negative 3. I'm going to add up 1 and negative 3. 1 and negative 3 add up to give me negative 2. And then I go negative 2 at the bottom times that negative 1 outside. It gives me a positive 2. And I add this up. If this takes place, if you get a 0 right there, that verifies that x is equal to 1 or negative 1. If I make this a binomial, you add 1 to both sides and you just get x plus 1. So this is one of my binomials. Okay? So what was our other answers? We just used negative 1, right? So now I'm going to go to negative 2. You okay with that? So negative 2 I'll use. I already used the negative 1. We're going to ignore that now. We're going to use negative 2 on synthetic division. Okay, so oops, come on down. So what I'm going to synthetically divide now is I'm not going to go back to my 2, 5, 1, negative 2. I'm going to take this. Okay, so I have 2, 3, negative 2. I don't worry about the 0. Okay, first move, this comes straight down. I take the blue 2 and the purple negative 2, multiply them together to get negative 4. Add those together. 3 plus negative 4 is negative 1. Negative 1 times the outside negative 2 is positive 2. Add those last 2 together, I get 0. This verifies that x is equal to negative 2. So what binomial would that be? Look above on the purple what I did with the x equals -1. Yeah, x plus 2. So that's my other factor. Okay? All right, now, because we saw we had 0.5 on our graph, right? I'm not going to synthetically divide by 0.5. Okay? That's cruel and unusual punishment to do, y'all. Okay? So, but what I'm going to do is I'm going to realize, okay, this top thing on my original problem, this was 2x to the third originally, right? So if I move down here, watch, ready? This was 2x to the third. This is now going to become 2x to the second. Is that okay? I'm just counting down. So if this was 2x to the third and this was 2x to the second, this would have to be 2x. So this portion down here becomes 2x minus 1, and that's my third answer. So my factor, hey, they're in. Beautiful. Thank you so much.
You're welcome.
Appreciate you. Okay, so my factored out answer to our problem is if I were to take x plus 1, that's what we originally found, x plus 2, which we found second, and this last remainder here, 2x minus 1. If I FOILed together these and then whatever that came out to, and then multiply by 2x plus 1, our answer would be this. Okay? So synthetic division is used as a good tool. You're very fortunate that we have Desmos available because originally what you had to do when doing this, there's have you guys graphed on the XY axis at least once? It's called the Cartesian plane. The Cartesian plane was created by a mathematician a long time ago named Descartes. It's spelled like Descartes, but it's Descartes. Descartes came up with something to do these, which was called the synthetic division. But what you did is you took all of the factors of -2 over all the factors of -1, and you tried to go through synthetically dividing until you got it to break down. Okay? But we have, the blessing of having technology available for us. And we'll go with that. Your last name, my friend? Were you able to get at least 5 or 6 of those problems done last night? That's the answer I was looking for. And I'll unmark you. Cool. All right. That's kind of big math. Okay? And I don't expect you to be perfect on it. I will tell you, there will be a quiz that I'll have one of those on. But we'll really push forward. What I'll probably do is if you're not totally comfortable with Desmos, what we'll probably do is say, hey, take a look at number 7. That's what the graph looks like. And then you'll have to go through and do the synthetic division and break it down, okay? Are there any other questions off the homework that I can help you with? We're good? All right. So I am on the next page of this packet. Looks like review 2. One of the big things on review of 2 versus review of 1 is review of 2, you have an equal sign, which means you're actually solving where it crosses the x-axis. So let's take a look at 1 through 9 first off. Just 1 through 9 on the algebra review number 2. Are there any problems on algebra review number 2 that stick out going, I would feel better if I saw that worked out between 1 through 9? Any of those I can help you with? Feel okay about them? 1 through 9? All right. Let's look at up through 12. Is there anything up through 12 I could help you with? We're good in the hood?
Could you do 11 or 12?
Yeah, you pick. I can do them both if you want.
11.
11? All right, number 11 on that next page. It says we have y equals 26 minus 3x and y equals 4x minus 9. We want to solve the system. So what that means is we're trying to figure out some ordered pair. Yes, you never have to ask. Just take care of yourself. We're trying to figure out some sort of ordered pair. So we're trying to solve what x is equal to and what y is equal to. Being these are both y equals and y equals, I can take both of these and set them equal to each other. And then start getting x by itself. So I might decide, let's add 3x to both sides. Those cancel. Let's maybe add 9 over to here. So those cancel. And that's going to give me 7x is equal to 26 and 9 added together, I believe is 35. So what does x have to equal? 5? So my first answer is 5. So now I have to figure out that y value. Okay, so I'm going to take this 5, which is an x value. I'm going to plug it into either of these. They're both set up as y equals. They will both get you the exact same answer. So top or bottom, your choice. Top, okay. So if I plug into here, I'm going to change that x to the 5. So 5 comma 11 is the solution. Okay. This should be a great problem to do as well because I told you you can use Desmos. I'd prefer you to use Desmos than a graphing calculator because 2 items. 1, you won't always have your graphing calculator with you. Item 2, I'm pretty sure your generation will always have your cell phone in hand. You might forget your shoes and socks at home, be out barefoot, but I can assure you you have your phone. Agree? So, now, if I were to do this one on Desmos, this would be, kind of fun to do in a mathematical sense of fun, which isn't fun really. But I think I stepped in. There we go. So if I did this one on Desmos, I'm going to clear out my old one that we did, and I'm going to go y equals 26 minus 3x. There's my first equation, so it draws this nice line. Go down to this next thing, and I'm going to put y equals 4x minus 9. And then Desmos, the nice thing about it is you can drag. You can say, well, let's zoom in. Let's make this thicker so we can see it a little bit better. If you click at the intersection, is that the answer that I got?
Yeah.
Okay. So you can do it one of 2 ways. Now, I can assure you that the tools of Desmos are very helpful, and I strongly encourage you, please, to have it on your phone, because yes, during a test or a quiz or even a final, I will looking for the honesty factor. I mean, we all know that photomath exists and it is pretty successful. But I would strongly encourage you not to have photomath on. I mean, photomath is a great tool, but I know it also leads to answers, and I'm not looking to see how smart photomath is. But Desmos, when you're doing this on your when you're during a quiz, I'll be walking around. I would like to make sure that your cell phone is flat on your desk. So when I'm seeing the face of your phone, I realize you're going to have 16 chiming things that take place on your social media. But underneath that, I should be seeing something like this that's on the phone. And the Desmos thing, is, it looks like a green chain link. It looks like, so if you go to your app store and you type in Desmos, it'll look like that little chain link, green chain link thing up there, which I think is a sine curve and a parabola, but it also looks like a chain link of some sort. All right. I want to go down to 13, 14, 15. And they're all going to be done the same way. But it's a little different thought process than just regular algebra. It says solve the following inequalities. Leave your answer in interval notation. Okay, so I'm going to just go to number 15. So we have 2x plus 1, x minus 5 is less than or equal to 0. So I'm going to solve this the algebraic way first. And then what I'm going to do is I'm going to show you something called the sign line. Okay, so as we look at this, it's going to be this type of thing, where I take each binomial with the inequality, and then I go ahead and solve it. Subtract 1, divide by 2, add 5. So if we write this in interval notation, if we look at just a regular number line, and this is going back to like algebra 1, we'd have negative 1/2 over here. 0 would probably be somewhere in here. 5 is way over here. So we think about, okay, I want x is less than half. So you have a solid dot here shading this way. And then I have a solid dot here shading this way as well. So it's kind of an overlap. So this is basically a negative infinity to 5 hard bracket. This hard bracket is because we have a solid dot. Okay? But I want to show you what Desmos will show what this is. This should be a parabola when we graph it. We want values that are less than 0, okay, or equal to 0. So if I did this using Desmos, I'm not going to worry about the inequality sign at this point. What I'm going to do is I'm going to say, okay, I'm going to go ahead and graph these two. And I'm going to make them as equal signs. So I'm going to y equals 2x plus 1 and x minus 5. And I have to change my settings a little bit, zoom it out. Okay. So basically, we're looking at 0. So my interval notation is slightly off. So I want values that are less than or equal to 0. So between here and here, this whole region is underneath the x-axis. So this is all where it's less than 0. Okay, so I have to go back and tweak my interval notation. But the nice thing is, because we have this available to us, this is verifying that my interval notation is wrong. Okay, so between negative 0.5 and 5, we're talking about values that are less than 0. Okay, but again, this is why we want to use Desmos, because sometimes the iterations of the algebra are going to show you slightly incorrect, especially if we do a number line. So this is going to portray this when I do it mathematically. So this is showing the wrong thing. The interval notation, and this is also wrong, the interval notation is I have hard bracket 1/2 to 5 is where our solution is less than or equal to. And because they have the equal sign, this little equal sign here is why we have the hard brackets. So that's where Desmos is going to help you. But the calculus portion of that, if you were to do something called a sign line in calculus, how you would write this on a sign line would be, okay, I'm going to put my critical values, -1/2 and 5. And what I'm going to do is I know that it's positive here, it's negative here, and it's positive here. Okay? Now this is probably brand new if you've never taken a calculus or a pre-calc class. This probably is a brand new concept. Okay? So this sign line is a lot of times in calculus, they'll say, hey, here's your sign line of your graph. So what this sign line basically means is I know that I am above the x-axis here because it's positive. I know I'm below the x-axis here because it's negative. I know I'm above the x-axis here because it's positive. The x-axis, remember, is this horizontal line. We're not worried about the y-axis in this case. Okay? This is what a sign line looks like. A lot of times they might put dots here and here. Those dots would indicate that we have the equal sign as part of the answer. If it comes to you as an open dot like this, that just means it's an inequality sign that did not have the equal component with it. So that's a much different idea than we're working with. Let's see where we're at. Okay. Got to remember, we're out of here quicker than... Okay, so why don't we stop there? I'm going to go, I'll be on the backside of this later. So on Algebra Review 2, I would say, why don't you look at doing 2 through 14 even? And you're just trying them. You might get stuck on something. If you get stuck on something, you know you ask about it tomorrow in class. Okay? Everyone good? Am I teaching okay still? Anyone crying themselves to sleep? If you are, I mean, hey, go for it.